Find the average velocity of the position s of t is equal t cubed plus 8t squared minus t. And on average velocity, we need to find on the interval from t is equal 2 to t is equal 5. Average velocity is total displacement divided by total time. So let's see, we are given s of t is equal t cubed plus 8t squared minus t. So displacement is going to be s is equal displacement on the interval between 2 and 5, it's going to be t cubed 5 and 2 minus 8t squared 5 and 2, actually plus, I'm sorry, and minus t 5, and here is 2. And let's see what we are going to get here. This is going to be equal. So we are getting 5 cubed minus t, minus 2 cubed, and then plus 8 times 5 squared, let me put parentheses, minus 2 squared, and minus 5, well, minus 2. Okay, and this is going to be equal 5 cubed. It's going to be 125, right? If I'm not mistaken. I don't think I'm mistaken. 5 times 5 and times 5. Okay, 125. 2 cubed is 8 plus 8 times 5 squared is 25 minus 4 and minus 3. Okay, 125. Well, all right, let me do this one also. Plus, so we get what? 8 times 21. That's going to be 168 and minus 3. So result is 268 plus 125 minus 8 minus 3, and that is going to be 282. 282, whatever measurement it is, let's say meters. Let me double check one more time. 125 minus 8, it's going to be 117. 117 plus 168, it's going to be 285, and minus 3, 282. Okay, we are good. So the average velocity is equal. So we are taking displacement of 282 and dividing by total time for this displacement, 5 minus 2. And we are getting 282 divided by 3. Okay, so how we figure out if it's divisible by 3 or not? So 282, I'm adding the digits. 2 plus 8 is 10, 10 plus 2 is 12. So 12 is divisible by 3, that means if sum of digits is divisible by 3, that means the number itself is divisible by 3. And we are getting average 94 meters per second. Okay, -1, or I would say the more proper way to write down meter over second. Okay, 94 meters over second. All right, now let's find instantaneous velocity for the same position of the function at the t equal 2. Okay, in this case, since it's instantaneous velocity, what we are going to do, we are going to take derivative. So ds by dt, let me make it more compact. There we go. All right, so, and this one also. Okay, so we are getting ds by dt, we are going to get, it's equal 3t squared plus 16t and minus 1, right? Okay, so at the point of t, I'm going to write down this way, s prime for t is equal to, or maybe it's easier write down like this. So t prime of t is equal to, okay, it's gonna be equal 3 times 2 squared plus 16 times 2 and minus 1, and it's gonna be equal 4 times 3, 12 plus 32, and it's gonna be 43. Okay, so instant velocity is going to be 43 and meters per second, and the average velocity is 94. Okay, what we can say that average is greater than instantaneous. But what's the difference? So if we're comparing, so what's the difference between average velocity and instantaneous velocity? Not mathematically, but meaning-wise. The instantaneous velocity is the specific rate of change of the position for displacement with respect to single point, okay? It's practically rate of change of the position at the specific point. In this case was 2. And while average velocity is a change over interval, okay, is a rate of change over interval. And graphically, the instantaneous velocity at any given point on some given function is the slope. So instantaneous velocity is the slope of that tangent line. Let's say, let me see. Is the slope of that tangent line. By the way, slope can be measured in degrees. So if you are driving car on the hill or driving down the hill, that's a slope under whichever angle. If you can drive on the hill by 30 degrees or 45 degrees, right? And slope is infinity or undefined, we say, when the rocket is taking vertically off, right? And its slope is 0 when car is driving on a horizontal line or on the horizontal road, okay? Then slope is 0. So instantaneous velocity identified by the slope of the tangent line to the function, while average velocity it's a slope of the secant line. Slope of the secant line. This is your secant line, right? Crossing beginning and the end, and there's an interval, right? That's why we take the distance it drove from here to here, right? And we divide by interval from this point A to point B. Okay, now so we understand now the difference between instantaneous and average velocity. Now how about if average rate of change, meaning average velocity, can be positive or negative? Of course it can be negative. Remember, you can accelerate, you can decelerate, right? When you accelerate, its average rate and instantaneous also rate can be positive. If you decelerate, then the average velocity, it's gonna be, or average rate of change, it's gonna be negative. Okay? Now, and I already explained that instantaneous rate of change can be 0 if you are driving flat. When it can be, let's say if I have f of x, hold on, if I have, let's say, f of x is equal 5, right? It's flat, it's a horizontal line, correct? This is 5, and the graph goes horizontally, correct? So slope is 0. All right. Now, if some of you are wondering what is the difference between speed and velocity, and if can speed be negative, speed cannot be negative. Speed is a scalar value, and if you add to scalar value also direction, it's going to become, the vector, which is velocity direction, it's going to be scalar value, speed plus direction. This is why when we have positive or negative velocity, it shows one way or another way or opposite way. Okay? All right, so that's all. It's I hope I made myself clear and you have no hesitation or doubt about difference between instantaneous velocity and average velocity. Okie dokie.